How NASA Landed on the Moon. A Story of Physics and Ingenuity, Part 1. The journey began on a Florida morning when the Saturn V roared to life, consuming thousands of gallons of fuel every second. Its first stage burned a mixture of kerosene and liquid oxygen, while the upper stages relied on liquid hydrogen and oxygen, chilled to hundreds of degrees below zero. Engineers kept these propellants in liquid form, using insulation and heaters to prevent them from boiling away. As the rocket climbed, it discarded empty stages like a swimmer shedding heavy gear, because every kilogram left behind made the next push easier. After 12 minutes, Apollo reached low Earth orbit, circling the planet at nearly 28,000 kilometers per hour. Here, something remarkable happened. The command module separated, turned around, and docked with the lunar module tucked inside the third stage, a delicate maneuver called transposition and docking. Once the spacecraft was assembled, the third stage fired again, performing the translunar injection burn. This added about 3.2 kilometers per second to Apollo's speed, placing it on a path toward the moon. Why didn't Apollo simply shoot straight to its destination? Because spaceflight is not a straight road. A direct path would have required an impossible amount of fuel and risked missing the moon entirely. Instead, Apollo followed an elliptical trajectory, coasting for 3 days. Inertia carried it forward, while gravity shaped its path. This slow, deliberate approach allowed for mid-course corrections and ensured that the spacecraft would arrive at the right place at the right time. As the moon grew larger in the window, Apollo fired its service module engine to slip into lunar orbit. From there, the lunar module detached and began its descent. Its engine was throttleable, allowing the astronauts to adjust their speed as they dropped toward the surface. Neil Armstrong took manual control in the final moments, steering past a boulder field and landing with only seconds of fuel remaining. Humanity had arrived. After exploring the surface and collecting samples, Armstrong and Buzz Aldrin lifted off in the lunar module's ascent stage, leaving its base behind. They rendezvoused with the command module in orbit, docked, and prepared for the journey home. A final engine burn sent Apollo back toward Earth. 3 days later, the command module slammed into the atmosphere at 11 kilometers per second, its heat shield glowing as it endured temperatures near 2,800 degrees Celsius. Parachutes deployed, and the capsule splashed down in the Pacific Ocean. The mission was complete. Apollo did not happen because of luck or secrecy. It happened because physics works. NASA has not forgotten how to go to the moon. The knowledge remains, but priorities shifted to the Space Shuttle, the International Space Station, and now Artemis. The evidence is undeniable. Retroreflectors placed on the lunar surface still return laser signals to Earth. Lunar rocks have been studied worldwide, and observatories across the globe tracked Apollo in real time. The moon landing was not a hoax. It was a triumph of science, engineering, and human will, a story written in the language of mathematics and powered by the laws of nature.